I'll tell you what's wrong here now. And you've heard this before. You've got all this matter in the universe. You have all these clusters of stars. You have clusters of galaxies, 1,000 galaxies all moving same direction, same speed. But there's not enough matter to hold them together. As a matter of fact, we are missing matter in the universe. We're missing it. The biggest problem is that we're missing more than 10%. Not really. We're missing more than 25, no, more than 50, no, I'm lying. Okay. We're missing upwards to 95% of the matter in the universe. 95% of the matter in the universe can't be accounted for. We need 95% more matter to make the stars stay glued together, to make the galaxies stay glued together, to make the galaxies that are glued to the other galaxies that are all traveling, to make them all stay together. We're missing 95% of the matter. And the astrophysicists, the rest of these guys, they have a name for that missing matter. It's called, what do you think? Dark matter. Dark matter. Okay. Once a week, promise. They haven't found it yet. Your taxes and my taxes are going to their research looking for dark matter. Because without dark matter, we cannot explain a single solitary thing that we're looking at out there. We need 95% more matter. Now, what do you think we're going to do about it? We're just going to pretend that it's out there. We've already named it. We have other names for parts of it, but we never can find it. What is dark matter? Dark matter is nothing. What you are looking at in terms of all of this design is God. That's it. I mean, God did not say, He put the universe together. He made the heavens and the earth. He created the heavens and the earth. And He purposely kept all the rules that He has put out here of our physics, all these laws, and He has said, I sustain everything. Doesn't He? I keep the world going around. I keep the sun shining. I keep everything going. It's my power. It's not the power of the sun that makes it shine. It's not the power of the Milky Way that makes it continue to spin. It's not that. It's my power. And to prove it to you, I'm going to show you that it all keeps staying in perfect clockwork time with 95% of the matter missing. You're looking at God's power. And you're never going to be able to put a measuring stick on it. You can never put God's power in a test tube and say, I found it. And we're never going to find dark matter because it's God's power. Now, if you had something that was operating and like a car, and you knew you ran out of gas, like a few years ago, but yet you always can start your car and keep going, what would you do? Would you say, I have dark gasoline? Or would you start looking for something else that might explain it? You see what I'm saying? Our biases are such that even the most obvious becomes confusing. Even the most obvious explanation becomes unacceptable because some people don't want to believe in God. And as Darwin set out and decided that he was going to ungod the world, he has done a pretty good job of it in the field of science. Next. No, next. Nope, stop. Phoenix Dwarf Galaxy, 13 billion light years from Earth. Okay? I mean, that's on the edge of the universe. 14 billion light years would put this thing, I'm sorry, I think this little guy should be 1.3 billion. That makes more sense. Take a note of that, my love. 1.3, and I'll forgive you. Wouldn't it be hard to live with somebody like me? I apologize. I heard that. Nothing like an informal discussion, right? Now, you've got this Phoenix Dwarf Galaxy in the central region of this galaxy. Now it's called a dwarf galaxy because it's a tiny galaxy. It's like 1/10 or 1/20 these little dwarf galaxies of our size. They're a little galaxy. And these galaxies, these little ones, are ones that were made early on, so they can be as far away as 11, 12, 10, 9 billion years, light years away, but they're past a billion light years. And now they've got a whole bunch of young stars in the middle of this, young blue stars. They're blue hot. They're not old red stars that have used up all their material. They're blue, young stars. And on the outside of this galaxy are the old red stars. Next. 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 Okay. The dwarf galaxies formed 1 to 2 billion years after the Big Bang. The blue population stars aren't any older than approximately 100 million years. Now this is, again, these dates are according to the evolutionist. So I'm using his facts and her facts and statistics to show you. So you have a galaxy that formed 1 to 2 billion years after the Big Bang. So it is sitting out there, and forget my decimal point, it's 13 billion. And you're sitting out there 13 billion years, and all of a sudden you have new stars. How'd that happen? How do you suddenly get something new from something old? It's old, it's burnt out. The candle is down to here, and the flame is just barely flickering, and all of a sudden, whoosh, and you've got a huge candle of power and light and everything, and everybody's going, what happened? Well, the evolutionist says, I don't know if he said that, but the evolutionist says there was a sudden rebirth of star formation. That's the answer. If you are a graduate student, you'd have to accept that answer. You can't say, what do you mean a sudden burst of, new bark? How's that? How do you explain that with the today's present laws of physics? And you'd get a bad grade. That's the answer. The answer is a sudden. It's unexplained because I told you earlier, there are so many things that you keep shelving. I don't have an answer. I just know that it happened, and you're going to have to accept the fact that although it goes against everything you have been taught thus far, just shelve it and leave it alone. Okay? But you can only shelve so much. Let's move on. Next. Here is globular cluster. The globular cluster of stars, all in one group. Next. More, I love this. All of these stars, you think are all being held together by gravity, by each other's gravity pulled in, and they are not. There is not enough gravity to make this star and this star keep going in the same direction at the same speed with this star down here. There's no reason why that thing should even exist, because it's missing 95% of the matter to keep it all together to make it do it. Next. Redshift. Next. Galaxy NGC 4319, Quasar Markarian 205. I told you, I promised you that I would show you something that destroys, that really beats hits right between the eyes. Holton Arp was working on galaxies and quasars. Now I've got to define a couple of these things, redshift and quasar for sure. Okay, some of you already know what a redshift is. A redshift, when you take light and you put it in a prism, it splits up into a rainbow of lights, right? Little lines. You can see it split up in that. Okay, that's a spectrum. Okay, every star that you focus on, you take that light and you run it through a prism and it forms a spectrum. And every spectrum is unique to that star. Totally unique to that star. So, we look at these stars and now we take that spectrum of that star, and if that star is going away from us, that spectrum shifts to the red color. If that star is coming toward us, that spectrum shifts to the blue side. It's very similar to when you hear, and it's not a pure analogy, but when you hear a train coming, and you see it, and it's coming and closer and closer, it gets louder, higher pitch, and then it gets lower and lower, lower pitch, the wavelength of sound, very similar to, in this case, to that of the stars and light. So, Hubble, the Hubble constant, Hubble came up with the fact that he linked distances of stars to their redshift. He said the further the stars shifted to the red, the faster it was going, and the faster it was shifting to the left. You got to think about that for a second. But it's gone, and he got a Nobel Prize. Hubble's law, I call it a law. Okay, it's very important because we look at the very supposed edge of the universe, and we need 14 billion years, the evolutionist says, to make evolution work. And Hubble has given us that because we can go all the way out, so we can see that the Big Bang had to have been at least 14 billion years ago. And that's enough time. We'll take that for time. So, Holton Arp now is doing his studying, and here's what he comes up with. Next. Holton Arp, using the 200-inch Palomar telescope, showed a luminous bridge connecting galaxy 4319 and quasar Markarian 205. Now, what's a quasar? A quasar is a quasi-stellar object. Quasar. Quasars are weird. They don't know what a quasar is. So they call it quasar-stellar object. So it makes sense to me. Dark matter can exist, so can quasars. So this quasar, though, is way out. Supposedly, quasars are on the edge of the universe. Okay? And you can see them with a telescope, a strong, powerful telescope. But yet the quasars are so small that for you to be able to see that quasar, it has to take 10,000 times the energy of our Milky Way. 10,000 Milky Ways all put together, way out there we can see the light. But yet the quasar is tiny. It's one light day in length. One light day in length. In other words, the time it takes for light to travel, the distance of that quasar, its diameter, is one light day. The Milky Way is 100,000 light years from one side to the next. This is one light day. We don't know. The astrophysicists can't describe what kind of an object that could be that could have such a powerful amount of energy radiating that we can see it and yet be that small. So, now we have a luminous bridge connecting this galaxy with this quasar. Next. Next. Okay. Here's the galaxy. Here's the quasar. A little story behind this. When it first came out, and Holton Arp published this, it got on the NASA website